Welcome to another session with Ms. Srilekha, lecturer in Mechanical Engineering, SRRS Government Polytechnic, Agra. In the yesterday's class, we have introduced ourselves with certain simple stresses, strains, and loads and types of loads. So, today we are going to discuss something regarding mechanical properties of the material. So prior to yesterday's explanation of simple stresses and strains, let us once rewind yesterday's class. And today our topic would be concentrating on mechanical properties of materials. So So in today's contents, today's objectives are we are going to have a fast revision of types of forces, stresses, types of stresses, strain, and types of strain, and we will be having a detailed explanation of mechanical properties. So yesterday already we have discussed uh, what is uh, what is strength of materials and strength of materials is nothing but the subject which deals with the behavior of bodies under the action of external loads. Next, we have also discussed types of loads. So, load is nothing but a member or a component that acts on certain component to uh, produce stress or to deform its body. Load is that member which deforms the structured member. Next, we have also discussed types of forces yesterday. So these types of loads or types of forces based on different criteria, we had different types. So according to the type of uh, the manner in which they are applied, we have two types. One is point load or concentrated load, and the second one is uh, distributed load. So this point load is nothing but the load which acts over a small area or at a point is nothing but point load. This point load can be expressed in newtons or kilonewtons. Next, we have also discussed uh, distributed load. So distributed load is nothing but the area, so the load which may be uniformly or non-uniformly distributed over a length or over a span or over an area is nothing but distributed load. So if the load is distributed over a span or over a length, then we measure it in Newton per meters. If this load is spread over certain area, then we measure it in terms of Newton per meter square. Thereafter, we have discussed types of loads based on nature of action. So static load. So static load is nothing but the load which remains constant for a particular period of time. So something, if we are placing any objects on any surface, that is nothing but a static load. So it would be remaining for some days or from hours or from years. So that is static load. So example, you can take a load hanging from a chain without raised or without lowered one. So that is a static load. Next, dynamic load. So dynamic load is nothing but which it is a sudden load or it is a falling load which will impact in a small fraction of second or in very small duration of time. If it is impacting, then it is said to be dynamic load. So example we have taken as The pile hammer dropped on a pile. A hammer dropped on a pile or a wooden plank. That is nothing but a sudden load. Next, fluctuating or cyclic load. So fluctuation or cyclic load refers to the load in which its magnitude and direction varies constantly. So example, we can take a load on a connecting rod of an engine. So the load which is acting on a connecting rod of an engine, it will vary in its magnitude and direction. Next, according to the effect produced, we have axial load, shear load and bending load. So again further this axial load can be classified into tensile load and compressive load. So axial loads are nothing but the loads which are applied along the longitudinal axis of the structural member. So if the load which is applied at the longitudinal axis of the structural member, that is axial load. Simply you can say that it's from the center line of that particular member. Say if the action of this load is to increase the length of the member, then that member is said to be in tension, and the load that is applied is nothing but tensile load. Next, see if the action of this member is in such a way that the load to shorten the member, if the load tends to shorten the member, then it is said to be a compressive load. So then the member will be in compression. Next, shear loads. So these are nothing but something like rubbing of the surfaces. So these are always perpendicular to the axis of the structural member, and it will tend to slide the surface with respect to other or to cut the part. So it will either slide the surface or cut the part. Next is bending load. So bending load is nothing but a transverse load that will tend to bend the structural member. Okay. So the load which will make a body to bend in a so the load which is acting in a transverse direction, and it will make the body to bend. So that is a bending load. Next comes stress. So as you know, when a load acts on a body, the internal resistive force, nothing but the strength that resists the deformation. Now, this internal force is equal and opposite to the external load applied. Now, this total resistance offered by that particular body per unit area of cross section is called induced stress or simply stress. So when load is acting on particular body, that body will try to overcome that load by showing certain resistance. Now this resistance is nothing but offered is nothing but stress. So stress is equal to load by area of cross section. So sigma is equal to P by A. Now it is measured in terms of Newton per meter square. Or Newton per mm square. Again, this stress. So depending upon the direction of the load, we have three types of simple stresses arising, inducing in a component. So first one is tensile stress. Say if the load acting along the axis and perpendicular to the area of cross section is nothing but axial load. Now if this axial load is tending to stretch the bar, so it is trying to increase the length of the body, it is nothing but tensile load, and the corresponding stress that is induced is nothing but tensile stress. So tensile stress sigma T is equal to tensile load by area of cross section. So here also same P by A, that P is nothing but tensile load. So tension is nothing but it will that force, that axial force will make the body to move away from the central axis. So it will try to uh, increase the particles. Next is compressive stress. So compressive stress is nothing but, so this is also an axial load. So this is something opposite to that of tensile load. So in this axial load will try to compress the body. It is something like pushing from the two sides. So when you are pushing a duster from the two sides, what happens? Its length decreases. So similarly, so when you leave it, it will get its shape, but when you are pushing it, it will come nearer. So this is nothing but compressive load, and the stress induced in that particular body is nothing but compressive stress. So for compressive stress also, the formula is compressive load by area of cross section. Next comes shear stress. So we already know shear load is nothing but it is that load, uh, tangential load, which will tend to cut or slide the part is nothing but shear load, and the corresponding stress induced is nothing but shear stress. So in this case, you are not going to make a body to increase its length or decrease its length. Here the effect of the load is tangential. It means one side of the body would may be pushed towards forward, whereas the downside of the one face will be as usual and the other face will be moved a bit forward or backward, and this is measured in terms of angles. So shear stress is equal to shear load by area of cross section. So next comes strain. So strain is nothing but when a body is in a state of stress. So nothing but when it is loaded externally, the deformation will occur. So a simple, if it is a tensile member say, then it will elongate. If it is a compressive member, then it will shorten. Now the ratio of change in length to the original length is nothing but strain. Simply the strain is a change in length by original length. That deformation by original length is strain. See here it is a dimensionless quantity, where in both numerator and denominator we are having only length. So strain is change in length by original length. Strain small e is equal to delta L by L. This is further classified into various types, that is tensile strain, compressive strain and volumetric strain. So tensile strain is that strain which is occurring on loading of the tensile loads. So in the tensile load, so you can make use of, so if a tensile load is acting say, then the length of the body will increase. Now the tensile strain is nothing but increase in length of the body by original length. So changing the length is nothing but present length minus original length. So present length minus original length is nothing but increase in the length. that is tensile strain. Again, coming to compressive strain, so compressive strain is nothing but again the strain developed or the deformation that is occurring due to compressive loading is nothing but compressive strain. So in this case the length is decreasing. So strain is equal to decrease in length by original length. Next comes shear strain. So shear strain is nothing but, so this is a measure of shear strain is simply in rotation of the planes perpendicular to the applied shear load. So as we have already discussed that only face of the body of the member will be distorted due to the shear load. So for this we take certain assumptions and derive the formula for this. So it is simply the shear deflection per unit length of the member. What is the deflection here? So we know that a face of the body will be rubbed. So when it is rubbing, it will displace from one place to the other place. So this deflection per unit length is nothing but strain, shear strain. So beyond this, we are having one more thing, that is volumetric strain. See, everyone is familiar with cube. So if you consider each face of a cube, if it is subjected to compressive forces, then this will result in a reduction of its volume. Now, ratio of change in volume to that of original volume is called volumetric strain. So, volumetric strain is simply change in volume by original volume. So, E uh, suffix of V is equal to delta V by V. So, in today's course of time, we are going to discuss something regarding the mechanical properties of the material. So, mechanical properties of the material will simply define the behavior of the materials when they are subjected to certain mechanical load. Say if you are applying certain mechanical load on a particular material, then uh, what are the different behaviors of that particular material can be simply defined by this mechanical properties. So there are few important mechanical properties. They are strength, ductility, malleability, brittleness, hardness, resilience, toughness, fatigue strength, creep, and one more thing is modulus of elasticity. So prior to this, if I take an example of a tensile test, so everyone is familiar that tensile test is nothing but, so it is one of the important test of metallic materials. So in which the specimen is stretched by the increasing load, and a certain result stress strain curve is produced. So that stress strain curve will give the behavior of the material under tensile load, and will mark certain salient points on that particular graph. So in that we'll be knowing all the ductilities, malleabilities, elasticities and all those. So let us first discuss about the strength. So strength is nothing but simply capacity to resist external loads under given condition. So you can simply say that strength is the ability of the material to resist a failure under the action of stresses. So if certain loads are acting, if the loads are acting, then stresses are produced. So that stresses can be resisted. So the ability to resist such stresses due to the loading is nothing but strength. Capacity, it is simply defined as the capacity of the uh, member to resist the external loads under given condition. So based on this strength only, we'll come across the term modulus of elasticity. So modulus of elasticity. We are everyone familiar with Hooke's law. So Hooke's law teaches us that within the elastic limit, stress is directly proportional to strain. It means when a body is loaded, so initially it would exhibit its elastic nature. It means whenever you remove the load, whenever you remove the load, it will regain its position. So to certain extent, it will behave as a in a elastic nature. So after that it will go for a plastic nature. So within this elastic limit, it means within the point where it will behave as an elastic member, so the stress is directly proportional to the strain. So if you take it in a mathematical derivation, so you can write it as within the elastic limit, the ratio of stress to strain is nothing but a modulus of elasticity. So stress by strain is equal to constant as per Hooke's law. So if I replace that constant with some letter E, capital E, that is nothing but modulus of elasticity. The modulus of elasticity is simply the ratio of stress to the strain within the elastic limit. So the metals with a high modulus of elasticity will possess high stiffness. So high stiffness means it will have minimum deflection under load. So modulus of elasticity is simply within the elastic limit, the ratio of stress to the strain is modulus of elasticity. Now the metals which are having high modulus of elasticity will have high stiffness. So if they are high stiffness, then they will have minimum deflection under the loading. Okay. Next, ductility. So ductility is nothing but the ability of the material to deform under tensile load. So it is something like wire drawing operation. So if you are applying this tensile load, it is nothing but the load applied on both the longitudinal axis and they will be moving away from the body. So if you are applying the load, so if they are softer materials, say if they are ductile in nature, they will not easily break down, but they will just deform. They will just change their shape, but they will remain in a continuous manner. They will be in contact with the other particles of the material. So this ability of the material to deform under tensile load is ductility. So this property will be facilitating us in wire drawing operation. Next, malleability. So this comes when you are applying certain compressive load. So the ability of the material to deform under compressive load is nothing but malleability. So when you are applying sudden compressive load, what happens? The materials will be simply, they'll be hammered. Okay? So this property can be used in rolling of the thin sheets, in rolling of the sheets, and so due to this effect only the metals can be hammered and rolled into thin sheets. Next, brittleness. So it is nothing but the ability of the material to fracture with very little deformation, simply breaking of the material. Example is highly brittle natured one is glass. What happens to the glass? When you are applying certain very small force, it will simply get fractured. It will simply something like breaks. So this brittle nature is nothing but it is simply defined as the ability of the material to fracture with very little deformation. That is brittleness. Next, hardness. So hardness, this is the most desirable property of the parts in order to whenever subjected to wearing. So wearing and tearing of the material will be very less part if the material is high hard one. Generally this hardened tools are used. Tools are used with high hardness. So it is simply defined as ability of the material to resist any abrasion. Abrasion is nothing but when you are applying certain abrasives or something particles like those which can uh, chip off the material when they are flown on the surface, on the surface of the material. So the ability of that particular particle to resist this abrasion or scratching of the material or indentation. Indentation is nothing but the it is the process of acquiring the shape of any tool. Say if I am using a press tool, that press tool when it presses on that particular body, its indent can be seen on the surface. So that is indentation. The ability of the material to resist all this indentation, scratching and abrasion is nothing but hardness. So hardness, this is considered mostly in the manufacturing of the tools. Next, resilience. So resilience is nothing but the ability of the material to store energy within the elastic limit. So it is something comes under without any permanent deformation. So without occurring the permanent deformation, as you know, within the elastic limit the body will regain its shape even though it is applied by certain loads, certain stresses are induced, but the body will regain its shape. So it is regaining its shape means it is resisting that stress, it is resisting that loads. So how will it resist? It will store the energy, it will make use of its internal energy to resist that particular loads. So this ability of the material to store the energy within elastic limit is nothing but resilience. So you will come across the term proof of resilience in further classes. So it is something, it is a desirable property for the parts which are subjected to impact loads, for the sudden loads. Next comes toughness. So toughness is property which will facilitate in deformation rather than in fracture whenever undergone by heavy load. So whenever a part is subjected to the heavy loads, so this will help in uh, the metal possessing high toughness will help in deformation rather than breaking of the material or fracture of the material. So toughness is that ability of the material to absorb energy before the fracture is toughness. So as you know, when you go on adding the load, so to some time it will exhibit its elastic nature. So after elastic limit, when it crosses, it will start showing its plastic nature. That is, it will change its shape. Its shape might be it will deform into some other shapes to it will start either elongating, or it will start showing its plastic nature. It will happen something like a plastic, and at a final at a ultimate point, it will fracture. That is, it will break down. So before that fracture, whatever the deformation of the material is occurring, so that will be uh, that will be facilitated by this toughness. So it is simply the ability of the material to absorb energy before the fracture. Next comes fatigue strength. So fatigue strength is nothing but the maximum stress under varying loads at which the material will operate without failure is called fatigue strength. So we have already discussed that when you go on increasing the loads, initially it would work as a elastic material. Then after it will start using like a plastic material or something before it fails. So it at a point it will break down, it will fracture. So till that fracture, whatever the maximum stress that is induced in that body before the failure is nothing but, without failing, whatever the maximum stress that can be induced is simply fatigue strength, or it can also be called as endurance limit. Endurance limit. uh, Next comes creep. So creep is nothing like uh, it is dependent on the temperature especially. So it can be defined as the slow and progressive deformation of the material with time at constant stress is called creeping. So this it is very important property to be considered while designing the component to withstand the stress while at relatively high temperature. Say if a body is subjected to certain load, so sometimes if it is highly ductile in nature or a plastic natured one, then the body will slowly go on deforming in its material. So this slow and progressive deformation is called creep. So this depending upon the temperature, these stresses even below the elastic limit can cause some permanent deformation. So this creep can occur even below the elastic limit. Say this is generally occurring when you are operating at very high temperature. So at very high temperatures, even though if it is elastic natured material, the particles in the material will start melting out, and they will exhibit this creep nature. It is nothing but slowly that body will start deforming. It will start taking the shape of another material. So this is all mechanical properties of the material. So let us once again rememorize. So today we have discussed something about the mechanical properties of the materials. So this mechanical properties of the material behavior can be uh, clearly pictured when the particle or when the member is subjected to certain loads. The most important mechanical properties that we come across are strength, ductility, malleability, brittleness, hardness, resilience, toughness, fatigue strength, creep, and modulus of elasticity. So, strength, it is nothing but the ability of the material to resist failure under the action of stresses. So, it is known as strength. So, it can be simply defined as capacity of the material to resist the external loads under the given condition. So next comes modulus of elasticity. It is simply within the elastic limit, we know that stress is directly proportional to strain. Stress is directly proportional to strain. Say this ratio of the stress to strain is nothing but simply a constant. So stress by strain is equal to constant. If I am replacing this constant by a term that is nothing but modulus of elasticity, that is nothing but simply our term. Modulus of elasticity is ratio of stress to the strain within the elastic limit. So it can also be called as Young's modulus. So the metals which are possessing high modulus of elasticity will have high stiffness. So high stiffness is nothing but minimum deflection under a load. So the next one is ductility. So the ductility is nothing but when you are applying the tensile load, the ability of the material to undergo the deformation is ductility. So this ductility is used for the wire drawing operation. It means the material, it will start elongating. It will start taking the shape of the required geometry, but it will not have any breaking or fracturing. It will just deform into the shape that is required. Next is malleability. It is the ability of the material to deform under compressive loads. So what happens when you are applying compressive load? When you are applying the compressive load, the sheets can be hammered. So the material will be suddenly hammered. Okay, and the rolling of the, they can be suddenly hammered, and the material can be simply rolled into thin sheets. Okay. So these all occur due to malleability. So this property will help in rolling of the sheets. The manufacturing of sheets can be utilized. Next is brittleness. So brittleness is nothing but the ability of the material to fracture with very little deformation. That is nothing but the brittle material will have low percentage of elongation. It is something like the glass. So glass are highly brittle in nature, means when you are putting very simple load, it will have deformed. So with very small deformation, it will start breaking. So that is brittleness. Next, hardness. So hardness is nothing but it is defined as the ability of the material to resist abrasion, scratching or indentation. So this desirable property is for the parts which are subjected to wear. So when you are regularly using a material, the wearing will occur. So generally the tools will get weared off because they are regularly used for the cutting operation. Hence we make use of hardened hardened tools for operations, for lathe operations. So this hardness is a factor that has to be considered when you are using the continuous operations which will undergo wearing of the material. So this ability of the material to resist abrasion, scratching and uh, indentation. Next is resilience. So resilience is nothing but ability of the material to store energy within the elastic limit. So that is without permanent deformation is called resilience. It is desirable property for the parts which are subjected to impact loads. It's nothing but for the sudden loads. Next is toughness. So it is nothing but the ability of the material to absorb before fracture is called toughness. So a part which is subjected to an impact load, uh, it will have greatly the normal load. So when the sudden normal load is acting, then the metal should have high toughness. So if the material is high tough enough, then it can absorb more and more energy before the fracture. Or else if it would be said as a brittle one, it will simply break down due to that uh, normal load. So this property will facilitate in deformation rather than a fracture under heavy load. If the body is high tough enough, then it would not fracture, but it will undergo a deformation, that is change in its shape. Next, fatigue strength. So fatigue strength is nothing but the maximum stress at which the material will operate indefinitely without failure. So before failure, whatever the maximum stress is there, the maximum stress up to which it can resist the loads is nothing but the fatigue strength. So this can also be called as endurance limit. Fatigue strength can also be called as endurance limit. So this is the maximum stress that can be withstand by the structured member. Next is creep. So this is simply if the this can be experienced when you are facing at a high temperature zones. So sometimes even below the elastic limits also this creep property can be seen. So creep is nothing but the slow and progressive deformation of the material with time at constant stress is called creep. So depending upon the temperature, these stresses will even be below the elastic limit, can cause some permanent deformation. So creep is very important property to be considered while designing the component. So to withstand the stress at relatively high temperature. It means the component should withstand to the high temperature. It should not simply deform when we are operating it at a high temperatures. So in today's class we have discussed all these mechanical properties, and in the next class we would be discussing about the tensile stress and the salient points that will be occurring when you are going for a tensile test on a universal testing machine, and how would you measure the percentage of elongations, ultimate tensile strength, and etc. And we would be discussing even Hooke's law tomorrow. We have already discussed Hooke's law. So Hooke's law is nothing but up to a proportionality limit, the stress is directly proportional to strain. And in the next class, we would be discussing even the elastic constants and the factor of safety and significance of factor of safety.